Hi guys, today we're gonna watch how GOM correlates software works. Actually, GOM correlates software is used for measuring data from 3D measuring or 2D measuring, from fringe projection, laser scanner, coordinate measurements machines, and other measurement systems. So, where GOM software actually used? Uh, the GOM software is used in product development or quality control or production, or obviously in research. So I will show today how the spores on a body are displaced with respect to temperature and time. So in this experiment, or in this video, I will show how the objects or how the points on shape memory polymer's body are displaced with respect to time and temperature, like that. So without killing any time, let's start. So this is the front of GOM software. This is 2021 version. So I haven't saved the previous ones. So first of all, we are gonna select the new project. Well, then we're gonna save this file. I'm gonna save this file to my folder. Well, first come first, the import of files. So we're gonna import the files. Speaking of files, actually the pictures should be in TFF format, and the rename should be in append form, like rename and the numbers 1 2 3 4 5 6 7, like that. If you wanna watch how to edit this type of photo, so you can watch my previous videos how to edit photos in photo in 2 minutes. By the way, I have selected the pictures, and I will select the deformation image, because we're gonna see how the objects are deformed with respect to time and temperature. Well, the pictures are captured with a steel frame, and the objects were not moved. The frame was not moved during the capturing. Well, the pictures are actually like 167 pictures here. So we're gonna see how the spores are moving, and we will also measure the displacement in x direction or y direction, or any displacements, or also strain, whatever you want. So it will just take some time. Well, I think it's finished. Okay, there's our picture. You can see here I have spotted 12 to 14 points. The object is very thin. The thickness of this object is 1 millimeter, and this is dyed in black by black color. And I have spotted these spores. The circle is about 1 millimeter diameter, and the distance between two circles are 1 millimeter. So you need to mark this type of circles or this type of points to measure or to analyze in GOM software. And also here you can see distance. So actually this is known distance, and the length of this distance is 10 millimeter, 10 millimeter, and 10 millimeter. This is a set reference or set measurement, so that for depending on this measurement, we will measure the displacement of this point. Well, the shape memory polymers can be extended in elevated temperature, and if we cool it down, it will memorize its previous shape, and if it is again kept in higher temperature, it will retain to its permanent shape. So this condition is the strain condition. So this is the view of inner oven. So this condition actually in elevated temperature. So with the elevation of temperature, the sample will be contracted because it is strained. Actually, this is a basic property of shape memory polymer. So we will see the displacement of these points during contraction, and it can measure up to 0.001 millimeter. Yeah. So without spending any time, let's define the known displacement. So we're gonna select the point 1 wedge. So for selecting displacing my pictures here. So for selecting one point, you need to press the control button and press the left mouse button. I'm gonna select the point 1 here, and here you can see the point 2. We'll select the point 2. So I will define it as 10 millimeter, but I wanna take more here, and if I zoom it, yeah, it's quite okay. So the point distance is 10 millimeter, I have said. I will press OK, and you can see here, if I press the left mouse button, it will vanish because it's a 2D picture, and it will not be appeared in 3D model. So you can also measure the displacement of any points of 3D model. So how can we get back to our 2D pictures? So select it here, image mapping, and here you go. So here you can see 0, 1, 2, 3, 4, 5, 6. This is the number of the pictures, and the first picture is defined as 0, and there I have told that there are 167 pictures. So the last picture's number is 166, but you can see the rename is 167. However, we have set the measurements here, and we're gonna select well, in some high quality pictures or in 3D measurements or GOM. There are many types of software of GOM, like GOM inspects. You can select the point component. There are many tutorial video in YouTube where you can see or you can watch the point component selection, but most of the time the point component is hardly to find. So in that case, you can select the facet point component. So you can also rename it. Say for example, I will keep that facet point component 1, the name, and we're gonna select the point. And very important thing is you can select the points in any point of this white area. So you can also zoom it here, but if you zoom it here, the quality will be decreased. So you can examine whether the points will be good or bad by zoom in or zoom out. So before selecting or before scrolling on the white surface or white circle, you have to press the control and you will find the pattern quality. So yeah, the pattern quality is quite important, because you can see if I scroll the points here, the pattern quality is quite changing. So I'm gonna check the as much higher quality as I can. So you can see here there is 5.8, so I will check 5.8 here, and sorry for that, I have taken the point and create and close. So if I have selected the first point, it will take some time actually, and you can see here the stage is going on. You need to wait for the first point, then second point and third point will not take this time. Well, the selection of facet point component 1 is done, and here you can see if there is no yellow line, then you will be assured that you can measure the displacement of this point from 0 to 166. Say for example, I'm gonna take this point, create and close. This is also there is no problem. Control Z. So I'm gonna show some flaws. Oh, there is no flaws actually, so it is very difficult to find. Yeah, I have selected here this point, so you can see here the yellow lines, the notice here. So in that point, in these pictures, the point cannot be notified, cannot notify the displacement. However, so we're gonna take successive two points so that we can differentiate the displacement and differentiate the difference of that of 2 points. Okay, so we have selected 2 points here, and we're gonna go this option. You can select the strain, major strain, minor strain, displacement. I'm gonna first select displacement here. Okay, and this is the levels. I'm gonna select the deviation levels, and with holding the or pressing the control button, I'm gonna select the facet point 1 and facet point 2. So you can see here the yellow line here, so you have to press the escape button. Yeah, you have pressed the escape button. You have defined in which direction you wanna measure the displacements. So I have selected a displacement, only displacement, not x-axis or y-axis or like that. or any strain. So let's see how it changes. You can see here the small portion of changes can be caught by this. Actually, the contrast of the picture also affect this. So you can see here the sample is buckling or contracting, and yeah, you can see the displacement here. Just press the button and just press the cursor. Well, so I'm gonna select the displacement Y. How it works like that, and you can also get the graph by selecting here. So there is no graph, right? We're gonna select their table content, 3D diagram, only diagram, 3D plus diagram. So I'm gonna select the 3D plus diagram. What happened? Sorry. So it's working fluently. Okay. You have seen that there is no graph actually, but the displacement is going on. Why the graph hasn't been appeared? Because you haven't labeled the points for displacement to the axis of y. So I have selected the points to the y displacement. Sorry, I have defined the level to the y axis, and here you can see the graph. Yep. Actually, this is the displacement, and actually these places are caught by the contrast of the pictures and some movements of the outside environment, but in our experiment we're gonna take the measure displacement here. You can see here, or you can edit or inspect the graph more precisely. Yeah, you can select here, you can just scroll down the points and you will get the coordinate. Now how we can save this data? Well, that's a good question. Actually, this is a open access, but you need to pay for exporting the CSV file, because for free access GOM correlate, it's impossible to export the files. You can see here. In other way, you can save the file, just a graph. Just press OK on the graph and wait for a second. Now it's done. So you can save the report here. This is the PDF, and you can save the PDF. Okay, it's actually already done before. And now you can see the PDF has been exported. So you can easily export the data from graph to data. There is another video of my channel, so you can follow that. You can easily export the data from this line without having since we cannot export the raw data from the software, so we need to find this data of this line. Okay, we're gonna save the file here, and until the next video, goodbye, see you, take care.